Hello and welcome to Wednesday's edition of Cracking the Cryptic. And today we have a puzzle by Rahman. I hope I've said their name right today. And this one amused me because basically it's a celebration of Rahman getting over writer's block, or whatever the SUDOKU equivalent of that is. So this is their latest puzzle, and it's got an enormous rating on Logic Masters Germany, so it ought to be brilliant, and only 3 stars out of 5 for difficulty, so in theory at least it ought to be approachable. Now, quick announcement. What we've started to do as of yesterday is we are releasing a cryptic crossword clue every day over on our Twitter account, which is at Cryptic Cracking, if you've not checked it out. This is today's fare. This is a clue by the UK comedian Dave Gorman, who I'm a big fan of in terms of his cruciverbal skills, his crossword constructing skills. Now the clue, solving Sudoku finally with a number, perhaps a lot of number 2s. Now this is an outrageous clue, and if you can't solve it, then get over to our Twitter handle, and there are a few clues there that should help you out. But be aware, this is slightly risque, but very amusing all the same. Now let's get back to this one. Anything else I want to mention before I kick off with the rules? Well, just do have a look over on Patreon at the moment. The Sudoku puzzle hunt that we released at the start of March is going great guns. It's themed on the wonders of the world, so there are, well, you should be able to know how many puzzles there are, but there's also a meta puzzle at the end, and yeah, I think we're heading up towards 300 correct solutions and a lot of very nice feedback. So if you think you might enjoy that, do check it out. It's not that hard, I promise. It's really not terribly difficult. Now, the rules of Tenaliraman's puzzle, let me read them to you. In fact, they're completely standard, so if you're used to our puzzles and you're used to the way we set them out, you will know already what the rules of this puzzle are. There are no hidden tricks. So we've got normal Sudoku rules apply. Clues outside the grid give the sum of the digits along the indicated diagonal, and digits along the diagonal may repeat if allowed by other rules. In the grid, the digits along the path of an arrow sum to the digit in that arrow's circled cell, and digits along the arrow path may repeat if allowed by other rules. Digits along grey lines form a palindrome, i.e. the sequence of digits reads the same forwards and backwards. So let's just quickly go through those so that we all understand what that means. So this 15 clue here, that's telling us those 4 cells there sum to 15. And it's absolutely fine for us to repeat digits along this diagonal if we don't break other rules. So what we can't do is put 2s in there, because that obviously breaks the rules of Sudoku in this box. But other than that, we could have 3 2s, in fact, along that diagonal. That would be absolutely fine. Stick a 9 there, and that works. So that's the little killer Sudoku rules. What else have we got? We've got arrow rules in the grid. So arrows are very simple, basically. You look along the arrow, you add up the digits in these 3 circled cells, and you put that in there. So if this was 1, 2, and 3, that would be a 6, etc. So nothing complicated. And then what have palindromes? Yeah. So palindromes, quite short palindromes today. And basically what that's saying is that we need to be able to read these lines the same backwards and forwards. Now these are only of length 3, so basically what this is saying is that these 2 cells on each palindrome must be the same digit, because if we read this way, it reads 1, 2, 1. If we start on this side instead, 1, 2, 1, it reads the same. So that's the rules. Do have a go. The way to play is to click the link under the video. I've got given digits today, I've just noticed. Fantastic. Now I get to play. Let's get cracking. And in fact, a real rarity, I've got little killer clues where I can just write the options in. If I've got to add up to 3 in 2 cells, well, that's got to be a 1-2 pair. Now, I wonder if that affects the 15 clue. So my thinking here is that these 2 squares have sort of, previously they had a minimum value of 3. They now have a minimum value of 7, because they can be a minimum of 3 and 4. But that doesn't, I think, limit the edges there, or at least not enough to be interesting. This could still be a 1-7 pair, which means there's an awful lot of options for those 2 squares. So I'm not that interested in pencil marking that. Now, what next? 33. In fact, we've got symmetrical 33 clues, look. Ah, that actually link the 15 clue. So we've got a sort of funny rectangle in the grid. But unfortunately, I don't know too many rules to do with funny rectangles. Empty rectangles, now that's a different story, but this is not an empty rectangle. Let's have a look at the palindromes maybe, because we've got to put the same digit on each palindrome end. So I can see that whatever's in those two squares, let's just do some colours, whatever's in these two squares obviously can't be in those two squares. What's less clear is whether this could be red. I think it could be. I mean, these two can't be blue, but they could go back to being red, which is very annoying, because that means that these 4 clues don't have nearly as much of a restriction on them as we might like. So I'm not actually sure that that's the way in. Right, I'm not doing very well here. Let me have a look. Let's have a look at the arrows. We've got 3 3-cell arrows where the arrow cells are all in the same box of the Sudoku. So the minimum value we could put into those 3 squares would be 1, 2, and 3. So these circled cells are all at least equal to 6. Now let's put that in. They don't see each other, so that's none of them are on a palindrome. The diagonal here, we've got a 36 diagonal, which is, so each box is roughly averaging 12 for the 3 cells. 12. Right, that is a little bit interesting actually, because the geometry of this diagonal looks like it's pretty deliberately avoiding the arrow cells. Let me just have a look at this. So what I'm wondering is whether there's a restriction, whether the fact that these cells in effect, I mean there's 9 of them, so they have to average 4. Does that mean that it's putting a restriction on the arrow cells? 6 cells, 21, 21, 63, 63. Ah, yeah, got it. Right, okay. I have a breakthrough. Right, let us in fact highlight everything. That is the way to see what I just did in my head, which is this diagonal. I'm going to highlight that, and I'm going to highlight all of the arrow cells as well. There we go, not the circles. Now, forget about the 36 clue, forget about the circles for a minute, and let's just ask the simple question, what is the minimum sum of these cells in box 1? Well, there are 6 different digits there, and if I put the lowest I can possibly put into them, I'll put 1, 2, 3, 4, 5, and 6 in there. Now, 1, 2, 3, 4, 5, and 6 sum to 21. So the minimum for all of these cells is 63. Now, we know this diagonal is 36, so we actually know that the other cells, the cells on the arrows, have to add up to at least 27, because the minimum I can make the purple squares altogether add up to is 63. Now, I can't actually make these cells add to more than 27. I can only just get them to 27, and that's with 3 9s. So that seems to me to be a big breakthrough. Although it gives us some digits. What else does it do? Well, I'll tell you what it does. We now know that the purple squares are the digits 1 to 6. So in each of these boxes, the white squares must be the 7s and the 8s. And the 7s and the 8s are on the palindrome. Oh, this is gorgeous. So we're going to be able to colour these in. Aha. Yes, I think this is going... Oh, why did that get highlighted? That's a mistake. Right. So... Okay, so let's colour these. We know those are the same. Let's make those red. So we need to find a different colour for this one. So we'll make that blue. So those are blue. That one, therefore, is blue. This one is red. This one is red. Oh, it's weird. The red ones sort of come down the bottom of the grid. The blue ones, yeah, the blue ones go across the top part of it. For some reason I thought it wouldn't do that. Right, so where does red go in box 7? That's got to be a red square. The only red square not in Moscow. Red. Yes. Now, look at box 3. Red has to be in one of those two squares, but the blues are telling us that this square is blue. So that's blue, that must be red. They're both still 7s and 8s. 7 and 8 by SUDOKU goes there, I think. Can we keep this going, or is it going to Oh no, we can. The blues pinch box 7 and force a blue into the corner. Blue must go here by SUDOKU. How many blues have I got? 1, 2, 3, 4. Nearly all of them. So there must be possible to get the 9th one. It must go here. And how many reds have I got? I've got lots of reds. 1, 2. That's got to be red. 1, 2, 3, 4, 5, 6. I've got all the reds and all the blues. This is some way to get out of your writer's block, isn't it? It's absolutely beautiful. And it's fun. Now. Nine is a little bit restricted just by SUDOKU in box 3 now. It's got to go in one of those squares. Whoops. Let's put it in those two positions like that. So 9's got to be in one of these two squares. Oh, I keep doing the wrong pencil marking. What's going on? 9 in box 7 actually is forced. It's got to go in this square. It can't go anywhere else. So, 9 in box 8 is now forced. Maybe we can do... No. Oh, yes. 9. This has got to be a 9. That's got to be a 9. 2, 3, 4, 5, 6. We've only got 2 more 9s to place, which must go in one of those two cells and one of these two cells. So we're just left with an X-wing on 9s. Can we resolve that? Yes, we can. There's a 15 clue staring at a 9 here. So if I put another 9 on this diagonal, that is a problem because it's already adding to 18. I can't put -1 and -2 into those other cells. So this is not 9. This must be 9. This must be 9. These two squares need to be deleted. And probably we need to look again at the 15 diagonal because it's got a 9 on it. This square can't be 1 or 2, so the minimum this can be is 3. So we're up to a total of at least 12 before we get to those two squares. Aha! This can't be 4. Because although you might think you can put double 1 in here, you can't, because there's a 1-2 pair in box 3, and you'd eliminate 1 from both those squares and force those squares to be double 2, which won't work. So this is a 3, this is a 1-2 pair. Now I'm wondering if I have to colour the 1s and the 2s. That would be sensational if that's the way this goes. Oh no, look, I've done most of the 33 diagonal now. Hang on, let's look at... Now, this is nice. Look, I know what the sum of these 4 squares is. Because they're different colours, they're basically 2 15 pairs. Oh, it is 1s and 2s. It is 1s and 2s because if these add up to 30, and they do, these two squares have to add up to 3, which means they are a 1-2 pair. So... Oh, I see. Look, it's symmetrical down here as well. This is the same logic. 33 on this diagonal. So these are 30. We've got a 1 or a 2. So, and now I'm going to actually just get rid of the purple, I think. And colour in the 1s and the 2s. Let me just check whether I'm meant to do... Am I meant to do Sudoku, or literally is it straight into colouring of the 1s and 2s? I want to colour them. I feel like they're calling to me. I'm going to colour them. Right, let's colour them. Let's start up here. That square can be purple, that square can be green. So this one must be green. Now that one therefore is opposite to that one. So this one becomes purple, this one becomes purple, that one will be green. That one must be green. Look, these greens force this to be green. Okay. This one must be purple. Therefore, this one must be purple, I think. Does this carry on, or do we crawl to a stop now? I don't know. I want it to carry on. I'm not sure I can make it carry on. I keep looking at these squares and thinking they're thermometers and thinking, now I can fill them in, but I can't, of course. Oh dear. Maybe there's something we can do with... Actually, I'm not sure. It feels like I can put that one as green. Let's carry on. 1, 2. These two are green. Right. I can get green in here because look at these two. One of those two yellow squares is green, and look in columns 7 and 9. One of those two squares is green. So we've not yet managed to put green, whatever green is, in the central row of the grid. And we can see it can't go in box 4 and it can't go in box 6. So it's got to go in one of those two squares, and it can't go here. So that square is green. Let's put that in. How many greens have I got now? I've got all the greens apart from this X-wing of greens. So let's look at purple. I can get purple here. I can get purple here because I've just got this green. So this now is purple. And can we go further? Oh, please go a little bit further. It doesn't need to go much. I can. Yes, here we go. I can just write purple into that square, can't I? By Sudoku. I can do that. Good. That's purple. Purple goes here. And purple goes here. So 2, 3, 4, 5, 6. I've got 9 purples and a small ambiguity on the greens. And there's got to be something in this grid that's going to disambiguate all of these 7s, 8s, 1s and 2s. Now what is that thing? I can see this arrow. That looks interesting. So this is 7 or 8. Yeah, that is interesting because look, you can't actually put a 1 or a 2 in either of these squares. And they can't add up to 9, so you can't not have a 3 on this arrow. If you don't have a 3 on it, they would have to be 4, 5, and this would have to be a 9. So if there's a 3 on the arrow, we can see where it goes. It goes here, which means there's a 3 down there. Doesn't quite intercept with the 3 we've got in the grid. This square must be a 4 or a 5. So 3 is in one of those two cells, 3 is in one of these two cells. Okay, and that's interesting. But it hasn't disambiguated the puzzle, I don't think. This is a 5, 6 pair in box 7. Right, so where does 4 go in row 7? We've got a 1, 2 pair, we've got a 7, 8 pair, we've got a 5, 6 pair. This is 4. So 4's got to be in one of those two positions. Maybe I've got to use the 9s. Actually, the structure of the 9 arrows is very interesting because if we look, there's one digit, the purple digit, is always on an arrow, and the green digit is always off an arrow. So if the green digit was 1, you'd put 2, 3, 4 on. If the green digit is 2, you'd put 1, 3, 5 on. And that would hold true across all boxes. And we have a 4 here. So there is no 4 on the arrow. If there's no 4 on the arrow, I can do it. If there's no 4 on the arrow, sorry, I'm wrong pencil marks. I want to put a 4 in the corner of that one. Now, let's look at this box. There's no 4 on the 9 arrow. Therefore, it is not 2, 3, 4. Therefore, it has to have a 1 on it, because there are only 3 ways of making 9 in 3 cells with 3 separate digits. 1, 2, 6, 1, 3, 5, and 2, 3, 4. Once the 2, 3, 4 is off the agenda, we must have a 1 in one of those squares, and therefore this square cannot be a 1 and is a 2. This is a 1. Purple is now 1. Let's switch to colours, and purple are 1s, or 1s are purples or something. Greens are all 2. All of these arrows now, all of the 9 arrows are 1, 3, 5. Look, and there's a 3 here. So this must be 3, this must be 5. And therefore in column 5 this must be 6. So 6 is in one of those 2 squares. And I think we're going to know how this plays out, because we must have 1, 3, 5 on the arrow. So the 3 has to go here, the 6 must go here, the 4 must go here, and the 5 must go here. And we are cooking with gas today. Sorry, I'm just wondering whether I can disambiguate this. I probably can somehow, I'm just not seeing how to do it. Let's come back up here, because we know that this arrow is a 3, 5 arrow. There's a 3 here, 5 here. These 2 squares have got to be 4 and 6. I'm not sure if we can do that. 3, this is a 3 by SUDOKU. 5, look, has to go in one of those 2 squares. That's not quite good enough. These 2 squares now have got to be 4 and 6. This square must be known. That must be a 3 by SUDOKU. 3 must go here. In fact, 3s must be done, aren't they? Yes, 3s are done. So somehow we just need to figure out the 4s and the 6s, and then we're probably... And yeah, so this is going to be what determines the 7s and the 8s. Which means I need to know whether this is 4 or 5. Maybe this column will be the key. We've got to put 4 and 6 into those squares. Oh, I don't like that at all. No, not 4 and 6. The reason, by the way, the reason I spotted that must be wrong was I saw this 4 and 6 here, therefore knew I would have to put 4 and 6 into those squares, and I couldn't see how to do that. So you can actually see there's a 6 here, which is what my misscanning was not spotting. So this is a 2-4 pair, and now we still have some useful information, because now I know there must be a 4 in one of those 3 squares, and the only place the 4 can go is here. So 4 and 5, 5 and 6 go in. These 2 squares, therefore, have got to be 2 and 6. And that's going to be nice, because that's going to give us these 2 squares. And we must be closing in. Yes, look, this 4 gives us a 4 here, which places a 5 here. Now we know that blue is 8, so we can click on the blues. I think that is just highlighting the blues. Turn those into 8s. Click on the reds, turns those into 7s. Add 6 to the grid here, 4 to the grid here. These 2 squares have got to be 5 and 6, which we can fill in. These 2 squares have got to be, what's that, 5 and 6 again. Okay, this 5, yeah, 5, 6, 6, 4, 4, 2, 2, 6. Looks complete. Click check. Yes, brilliant. Absolutely brilliant. What a way to get unstuck from your writer's block, Tenaliraman. I loved that. That was not too difficult today, but it's so beautiful. It really is. And the solve path is to die for. So the opening trick is lovely. It's not too difficult to see, but there's no harm in that sometimes. So we were able to deduce that these were all 1 to 6 combinations. And that gave us the 9s. And the 9s, and it allows us to place these 7s, 8s. And the way the 7s, 8s went round the grid using the palindromes was beautiful. And then we could do the same with the 1s and 2s. It's just gorgeous. Fantastic. Loved it. Let me know in the comments how you got on. I do read them. I do enjoy them, especially when they're kind. And we'll be back later with another edition of Cracking the Cryptic.